Welcome to the Optics Valley 2021 celebration of the International Day of Light. We're your hosts for a tour of some of the optics and photonics companies located right here in Southern Arizona. I'm Olivia Fehlberg. I'm an optical and optomechanical design engineer with Edmund Optics located in one of our Tucson facilities. For my job, I get to design optical components and assemblies that go into all sorts of markets, ranging from factory automation to laser manufacturing, medical diagnostics to communications and more.
Hi, and I'm Lukas Gruber, responsible for business development in medical, scientific, and industrial markets at Leonardo Electronics. In my role, I'm working with a wide range of international customers exploring how high-powered diode lasers can help them create new products and advance research in science. Olivia and I had the opportunity to talk to representatives from several outstanding optics and photonics companies in town. We're going to show you around and let them tell us what they do, why or how they landed in Tucson, as well as how they see the work that they do affecting the future.
We are so looking forward to giving you a glimpse into our local optics and photonics industry and all the opportunities it has to offer.
So my name is Robert Walker, and I am Vice President of Sales and Marketing at Leonardo Electronics US. And essentially, my responsibilities are business development for the laser diode business here in Tucson, Arizona. We make laser diodes, so we make laser products for a range of markets and applications. In terms of market space, we make laser diodes for advanced targeting lasers. So these are lasers that are used to identify targets for smart munitions, for example. We make products for medical applications. So lasers are used in many different applications, and we focus primarily on aesthetic laser applications, and the most prominent of those is laser hair removal. So our lasers are used to remove hair from people's bodies where they don't want hair. We make lasers for material processing, so the fabrication of materials, cutting and welding. We also make lasers for scientific applications, so very high energy lasers, petawatt class lasers.
I'm the CEO, President, and founder of Advanced Photonics. Yeah, we build fiber lasers. Basically, you try to utilize the specialty glass and the fiber itself. So our products is fiber lasers, fiber amplifiers, but inside always have a piece of specialty GaN fiber inside. So in terms of market-wise, we started as SBI company, and we get into scientific market. Nowadays, we really try to focus on industrial applications.
My name is Nasser Pegambarian. Thanks, Lukas, for making this happen. I'm the CEO of NP Photonics. I'm also a professor at the University of Arizona College of Optical Sciences. So at NP Photonics, we build lasers, and these are specific lasers which are called fiber lasers, which means that inside the laser, there's a piece of fiber that is generating the light. These applications range from defense and security to all the way to medical lasers that are used in surgery and medical field, all the way to communication and sensing.
My name is Greg Quarles, and I am the CEO and president at Applied Energetics. So our company primarily focuses on ultra-short pulse lasers, as well as high voltage and the direction of light and voltage together in the form of a directed energy, laser guided energy concept. And our primary markets are 8 government agencies, U.S. Department of Defense, as well as a few manufacturing areas, dual use applications in the additive and subtractive manufacturing areas, as well as manufacturing of components using ultra short pulse optical sources in the biomedical and medical device applications.
So my name is Katie Schwartz, and I am a design engineering manager at Edmund Optics in our Tucson office. And so actually for the past 10 years, I've done optical and optomechanical design, but recently I've moved into a management position. And so now I oversee some of our design group, and I help to make sure we have the right resources to get design work done for the company. So Edmund Optics is a global manufacturing company of optical components and optical subassemblies. So we manufacture, we do our own design, and we help customers go from prototypes to production level products. So optics is a bit of what we call an enabling industry, in that it is in a lot of other markets. And so we basically sell to other businesses and other markets outside of optics to help enable products that you as a consumer or a customer would buy off the shelf.
So my name is Robert Shroder, and I'm Vice President of Operations for Optical Support. My role, in addition to kind of the day-to-day operations of the company, are primarily engineering, contracts and customer management, and new business development. So optical support, as the name may imply, is an optical engineering services firm. We specialize in the design, fabrication, assembly, and test of optical subsystems for markets like semiconductor, aerospace and defense, biomedical, commercial sensing. So one of the bigger systems that we've done to date was a large interferometer system that was used to test silicon wafers during deposition of computer chips or electronics chips. Mm-hmm. That system was about 7 feet tall. It weighed about 1,800 pounds.
Wow.
And those systems are now in use in chip manufacturing plants around the world. The largest of those custom lenses that we built was a 25 element lens that weighed over 225 pounds.
So just to give the people at home a little frame of reference, your your camera lens for your Canon or your Nikon tends to have, maybe 7 to 9 elements, and they don't weigh that much nearly at all. So that's a pretty massive lens.
Hi, Lukas. Thank you very much for the opportunity to speak to you today. My name is Kate Medicus. I am the CEO of Rudo Cardinal. Rudo Cardinal is a custom firm. So what we do is we take any customer's needs in terms of solving an optical challenge. One of the things that we're working on right now is a camera for a satellite repair mission. So that's an application where we talk about very challenging environments. You've got very cold and very hot environments in space. So right now we're building an instrument that uses light to measure a biological sample, and that we can detect certain viruses or certain bacteria in that biological sample, and that will greatly enable speed in testing of those biological samples. And we understand how important that might be right now. What markets we touch? So we touched on some of the space exploration and the scientific work study that we do. Biomedical instrumentation is something that we also do. Defense work, helping our warfighters and our country in that regard is work that we do also. We also have touched on commercial applications. We've built a system for Hollywood for a better camera so that we can get nice movies that we do like to see. So we're in a wide range of industries, anywhere that somebody needs light to do something.
So, yeah, my name is Bob Norwood, and I'm founder and Chief Technology Officer at Norcon Technologies. So Norcon Technologies is developing optical components for infrared optics. Thermal imaging is an interesting area, and that touches healthcare. Another area that's interesting is it's a really emerging area, and you can see this now if you have one of the latest handheld smartphones, using infrared light, but not very far infrared light, for what's called 3D sensing. So the way the latest iPhone looks at your face is it has a bunch of little lasers in the phone that send their light out, and then they look at the light that scatters back from your face, and they use that information to figure out that it's you. That's just one example of a really growing area that we broadly call 3D sensing.
So my name is Michael Hart, and I'm the founder and currently the president of Hart Scientific Consulting. So anytime we're trying to look through the air for whatever reason it might be, if you're an astronomer trying to look at a distant galaxy or a quasar, it would be very nice if you could just make the atmosphere go away. And that's a little hard to do, and it might have some disastrous side effects, like we wouldn't be able to breathe. But fortunately, there are other optical methods that we can use to mitigate the degrading effects of the atmosphere on our imaging systems. And to do so, we use the techniques of adaptive optics, so-called. And that is what Hart Sci is really all about. It's making blurry images sharp again.
Yeah, my name is Craig Ament, and I'm the founder of Arizona Thin Films, which is an optical coating manufacturer here in Tucson, Arizona. Arizona Thin Films manufactures optical coatings for lenses and windows, and we do this by depositing very thin layers of material. And so, how thin is thin? What do I mean by thin? Well, typically, the layers that we deposit are about 100 nanometers thick. And to relate that to something that you can understand, a human hair, on average, is about 100,000 nanometers thick. So about 1,000th of the thickness of a human hair is the size of the structure that we're depositing. And if we design these thin layers correctly, we can create optically interesting films, which would allow us to control the amount of light that is either transmitted through the glass or reflected by that glass. So that's, technologically speaking, what we do.
My name is Neil Brock, and I am the technology director with 4D Technology. We design and manufacture laser metrology systems. These systems are used for testing primarily large optics, and these large optics are used in Earth-based, space-based telescopes, space probes, spy satellites, Google Earth imagery, all those kinds of things. And what we do is we can, our systems will measure these surfaces so that they're perfect, so they can create perfect images. The big programs we've been involved with over the last few years are things like the James Webb Space Telescope, which hopefully will launch later this year. Keep your fingers crossed.
Right. I forgot about that. Yeah.
Yeah, it's way behind schedule, but there's a lot to it. It's one of the most sophisticated scientific instruments ever made. And every aspect of that instrument, all of the optics, the primary mirror, the secondary, tertiary, the IR camera, the structure that holds all the mirror segments together, every one of those things have been tested with 4D metrology equipment.
I'm Tyler Steele. I'm the product manager for laser interferometer products at Zygo. That's everything laser interferometer product related, from marketing to applications to things like material sourcing and interfacing with engineering and R&D and product development. So Zygo is pretty well known for the interferometer products, and I'm showing one here behind me over my right shoulder. So interferometers are used to measure typically used to measure the surface of things like optics, like optical elements, like this, like Edmund makes many of. So we measure the surface. The instruments measure the surface of optics while they're being produced as a feedback for the polishing process to understand where polishing needs to happen more or less. But they're also used to measure things like the imaging performance of, for instance, things like a camera lens for wavefront performance, or MTF.
My name is Jerry Knight-Rubino. I am the CEO and founder of Photonics Automation Specialties. And my job is to, of course, run the business. And I'm also the lead engineer here. So I do direct both the day-to-day direction and the strategic direction of the company.
Hi, my name is Jiao. So I joined Photonic Automation about a year ago. So my main responsibility is for marketing and developing the business. I'm also the principal investigators for some of the research grants that we submitted and applying for.
We started as laser test engineers, high power laser test engineers. And that's what our main product until recently has been high power laser test equipment. Just recently, in the last year or so, we've started to get into a side business, which is now possibly becoming our main business, we'll see, of environmental sensing. And this is optical sensing of environmental or other data. And that is also a parallel effort for us.
Yeah, I would just say that our new effort, we're mostly focusing on remote sensing and technologies related to that. And we currently, one of our big application is in the environmental side. That would include sensing of ocean and sensing of forest and soil.
Gary Sims, and I am the Chief Technical Officer and President of Spectral Instruments. I'm also the President of Spectral Instruments Imaging, another company here in Tucson. Yes, Spectral Instruments makes electronic imaging systems used for scientific measurements. Sort of equivalent to a camera, you may take a picture of something with, but it's used again to make an accurate measurement, typically of intensity. The easiest application to appreciate is the cameras used for astronomical imaging. Not for amateur astronomy, where you're looking at something to get a pretty picture of it, but of an application such as used on the Catalina Sky Survey, where you're looking for an object moving through the sky and you need to know how large it is, how fast it's moving.
So I'm Andy Griffis. I'm the CEO of the Sensor Group here in Tucson, Arizona. We're about an 11 or 12-year-old company founded in 2009 to serve the interests primarily of the U.S. Navy. But what I do is I'm the CEO here in a small company that does technology. That means what I am is a business technologist. And that means further that I provide both strategic and technical leadership to my company. My background is electrical engineering, which in Tucson means, for me anyway, you work on imaging problems that involve electro-optics or electronic devices, digitizers, and computers, always computers. So we focus primarily on the needs of the U.S. Navy for imaging solutions for problems that they encounter in mine countermeasures. Now, our part of those solutions is providing receiver technology. So a LiDAR has both a receiver and a transmitter. We're focused on the receiver technology for marine LiDAR systems that they use to keep our sailors safe and our sea lanes free of debris, of things that can blow up, and of course of anything enemies would place there to keep us from doing business that keeps us all fed and clothed and sheltered.
So now that we've met everyone, why don't we learn a bit about why Tucson is so special to optics?
But overall, Tucson and Arizona in general are just ideal places to do business. And I think you're kind of seeing that with a lot of companies moving here lately. So
we would like to believe that the growth that we've seen in the company in the last few years will continue, and that we'll continue to provide meaningful employment for optical and mechanical engineers coming out of U of A or potentially coming from elsewhere.
My colleague here, Professor Pagan-Berrien at the University of Arizona, so I'm also a professor at the University of Arizona, just called me out of the blue late one December day when I was working on the basic asset sale of the company to myself, and said, "Hey, you ever think about being a professor?" And I said, "Well, yeah, maybe about 20 years from now." I mean, I really wasn't thinking about being a professor. I did have a long-term plan, so I came down here and I really loved the way that optical sciences was set up from a point of view of really being applied research driven, being very entrepreneurial.
It is a very cool thing when James Webb Space Telescope starts creating these incredible images that are going to blow everyone's minds. We had a part of them. That's something to be proud of. And all the engineers and technicians and all the other great people we have here, it's a team effort. And they've all had a hand in that, and that's something they can all be proud of. And I think hopefully it's something that Tucson can be proud of, because the university had played a major role in James Webb Space Telescope. Jim Wyant was on their advisory board for many years, so definitely it'll be a moment for Tucson to be very proud, I think.
And I think there's just a basic thing, a basic principle that optics are going to continue to be essential and be even more essential as we develop new technologies and as we develop new ways of viewing the world.
EO does have our tagline, "The future depends on optics," which it absolutely does, and also our present relies on optics. Our past has relied on optics a lot. So I think a lot of people don't realize how much optical technology underlies a significant amount of their everyday. So a lot of the technology you use, from things that right now are as basic as the internet, enabled by Fehlberg communications, things like your cell phone camera that are pretty ubiquitous, and now we look into the future of robotics and self-driving cars that uses imaging. So there's a lot of places where optics is being used, which is really critical to your everyday.
We all need to do international commerce, whether we think about it or not. And access to the sea is what the U.S. Navy is for. So keeping the sea lanes clear is a really big deal. And so we're very happy to be able to play a role in that and help enable the Navy to do its job, which is to keep us all in business.
Lukas and I and all of Optics Valley would like to thank everyone for their time and hope that you have a wonderful International Day of Light celebration this year. For more information, feel free to go to the link above, lightday.org, for all the fun stuff about the International Day of Light.
In closing, I would like to thank all the contributors that made this medley of optics and photonics companies in Tucson possible. I hope all of you got as much out of it as Olivia and I had fun putting it together. It reinforced my impression that Tucson is a power player in this industry. I'm looking forward to the next International Day of Light event when we can meet in person and shake hands.